Imagine you're traveling in the foothills of the Rocky Mountains. Snow crunches underfoot as you explore the frigid winter landscape. You set up camp as the sun sets over the mountains. When you wake the next morning, it's a very different scene. Strong winds sweep across the plains, the air warm on your face. The snow surface has melted into an icy crust as the frozen landscape starts to thaw. It's at least 20 degrees warmer now. What happened? My name is Taylor, and today we are going to learn about the fascinating phenomenon known as Chinook winds. If you like learning about human and natural history, consider subscribing to The Yellow Bird for more content like this. Chinooks are warm, dry, westerly winds that occur on the leeward side of the Rocky Mountains and cause sudden warming. Chinooks occur due to the geography of the Rockies themselves, and this phenomenon has wide-ranging impacts on the ecosystems and people that call the foothills home. Air currents, known as westerlies, carry moist air from the Pacific eastward into the continent's interior. When this oceanic wind reaches the Rockies, the air is forced upwards and over the barrier. This process is known as orographic lift, from the Greek word for mountain, oros. The air cools as it rises, causing moisture to condense into clouds and fall as precipitation on the windward side of the mountains. The now dry air mass crests the mountain range and travels down the leeward side of the mountains. As it descends, increasing atmospheric pressure compresses the air, which warms it. This warm, dry, downslope wind is a Chinook. In some cases, temperatures can rise by 25 degrees Celsius in a matter of hours due to Chinooks. But how? A few factors contribute to the stark spike in temperature. Number 1. Water condensing on the windward side of the mountains returns latent heat to the air mass, though this only warms the air slightly. Number 2. The downslope wind warms as it travels down the leeward side of the range. This warming occurs adiabatically. Diabatic processes cause heating or cooling as the result of heat exchange from one source to another. Solar radiation is a diabatic process, since heat from the sun is transferred to the Earth and its atmosphere, warming it. Adiabatic processes do not involve heat transfer. In adiabatic processes, temperature change occurs without heat transfer due to the compression or expansion of an air mass. Atmospheric air pressure decreases as elevation increases, since there is physically less air exerting pressure downwards. As Chinook winds descend the Eastern Rockies, the increase in atmospheric air pressure compresses the Chinook air mass, causing it to warm quickly. This process is the primary cause of warming experienced during a Chinook. However, Chinook winds in Alberta often replace cool Arctic air that originates in the north, exacerbating temperature changes caused by Chinooks. The word Chinook, originally pronounced Chinook, is the name of an indigenous people who live near the Columbia River in the Pacific Northwest. This area experiences similar gusty, warm winds, which French fur traders called Chinooks after the indigenous people who lived in the region. Traveling with French fur traders, the term's use expanded to refer to similar winds in the Columbia Plain and later the northwestern Great Plains. While they use the same term, it's worth noting that coastal and interior Chinooks are caused by different processes. This video describes the process behind interior Chinooks, since those are what we get in Alberta. Chinooks occur regularly in the Eastern Rockies and foothills of Alberta, Montana, and Wyoming. They occur year-round, but are most pronounced in the winter when temperature fluctuations are more noticeable. While the term Chinook is exclusive to Western North America, the phenomenon behind them is not. Similar winds are found around the world, occurring where wind currents blow perpendicular to mountain ranges. As a rule, the taller and steeper the mountains, the more pronounced the effect. In the European Alps, these winds are called Föhn. South Africa has Bergwind, Bergwinds blowing down the Great Escarpment. There's El Viento Zonda in the Argentinian Andes, and New Zealand's Southern Alps have nor'westers. All of these are caused by the same combination of wind currents, orographic lift, and adiabatic processes as interior Chinooks. They just go by different names. Chinook winds have an array of effects on the environment. Before they're felt, their effects can often be seen. These winds are turbulent, and when that undulating air flows upwards, Any remaining moisture condenses high in the atmosphere, creating a cloud formation commonly referred to as a Chinook arch. These massive blankets of condensing water over the foothills are even visible from space. In the Alpine, Chinook winds redeposit fallen snow on leeward mountain ridges, which can cause wind slab avalanches. Slab avalanches are the most dangerous type of avalanche and occur when snow accumulates and compacts, forming a dense slab, which cleaves in massive sheets when snow layers aren't adhered strongly to one another. Hot, dry Chinook winds also melt snow, desiccate plants, and dry and erode soil. It's part of the reason why the Eastern Rockies are so much drier than the Western Rockies, though the rain shadow effect also plays a role in the area's aridity. I have a video that explains the effects of the wind shadow in British Columbia that you can watch after this one. Plants here are adapted to hot, dry, and windy weather, and irrigation is vital for the region's agriculture. Crop rotation is also utilized to help retain soil moisture and prevent wind erosion. That's all for today's video. I hope you learned something new. Now I'd like to hear from you. Do you live somewhere that experiences Chinooks or similar? Are there any fascinating phenomenon where you're from that you'd like to share? I'd love to hear from you in the comments. If you want to learn more about Chinooks and their effects, head to my website, theyellowbird.ca, for a longer article. I also have several videos about the Canadian Rockies for you to watch on my channel. Don't forget to like this video and subscribe to The Yellow Bird for more content exploring human and natural history. Thank you so much for watching and have a lovely day. Bye-bye!